Now we have to be able to define dark areas on our map. Unfortunately, Unreal Engine doesn't provide any tools to do it, and after a little bit of time spent on ways of implementation such system, I decided to do it using tracing. Also, I think it can be done with scene capture component and processing an image of a player, but I think that it will take a lot of resources and I don't think that it is needed. So now let's start. Let's create a new folder called darkness detection and create new actor component. Call it BP darkness detection. Open it up. Here get an owner of a component and promote it to a variable. Or let's cast it to a character. Cast to a character first and promote it to variable. Call it character. We also have to get a sun. We need to get a sun from our map. In my case, I'm using Ultra Dynamic Sky. If you're using it also, just open Ultra Dynamic Sky blueprint, select sun, in search type tag and add a tag for a component and call it sun. If you're not using Ultra Dynamic Sky and you just have a directional light actor, select an actor first, add a tag for an actor here as a sun. Next, get a component and add a component tag as sun. And now I'm gonna delete it. This custom directional light. Also for Ultra Dynamic Sky, select a whole actor and add an actor tag. And call it sun. Now in darkness detection, let's get all actors with tag. And tag is gonna be sun. And we have to check if an array is empty first. If it is not empty, we're getting the first one. Get a copy of the first one. Here we're gonna get component by tag. Component class is gonna be directional light component and tag is gonna be sun. We also check if this array is not empty. Add in a branch. And if it is not empty, then we're getting a first component and promoting it to a variable and calling it sun component. Now let's create a new function and call it grid scan around player. This function will spawn a grid locations around the player in some distance. So if our player, let me add it on the map, somewhere here, we will scan from a sun direction somewhere on the dot around the player. We have to generate locations to which we're gonna trace. So grid scan around player. First here, let's get a character and get actor location. From here, we're gonna, from this central point, we're gonna make a grid. First, let's make an input of type integer and call it cells count half. Now we're gonna do a for each loop. Not just for each loop, we're gonna do for loop with break. Or not with break, just for loop without break. And the first index is gonna be cells count half multiplied by -1. It's gonna be first index. And last index is gonna be cells count half. Next, we're gonna make a vector and we're gonna break an actor location. Right click on return value, split struct bin. Here, we're gonna add one more for loop. Just copy this one and paste it here. Let's promote an index of a first loop to a local variable and call it local x index. And promote an index of a second loop to a local variable and call it local y index. Now we're gonna get a local x index and multiply it by some value. We need to multiply it by spacing between grid points. Let's create a new variable here and call it grid scan spacing of type float. And by default, let's make it 10. So now we have to multiply local x index on grid scan spacing. First, let's convert this 0 to a float, right click on it and select float single precision. Next, connect grid scan spacing to this multiply function. We should do the same with a local y index. Just copy it and paste it here. But instead of local x index, connect local y index. Now, from a get actor location, we're gonna get return value x and add first multiply result and y, and also add a second multiply result. Maybe like this. And this goes into a new vector. X goes into x, y goes into y, and z goes into z. And this is gonna be our points. Let's draw a debug sphere for them so that we will see where they are located. Right after that, let's call draw debug sphere with a center at this make vector position. And the radius of 5, line color will be red. Duration of 2 seconds. Now when we're gonna call this green scan around player, we're gonna call it on some timer when it fires. Let's create a separate function and call it scan. And on event begin play, let's move our setups a little bit to the right and add a sequence node by holding S keyboard button and left clicking somewhere in an empty space. Collect then 0 to our first graph, and on then 1 we're gonna set timer by function name. Function name is gonna be scan. We're gonna scan every half of a second and make a timer looping. Now open scan function, and from scan function we're gonna call grid scan around player. We have to provide it with cells count half. I think that 4 will be fine. Let's test it out. To test it out, let's first add this component to our player. Open your character and add new component. Call it BP darkness detection. Compile and save. Let's start. Now you can see that debug spheres are drawn here, but spacing is too little, and I think there are too much of these spheres. Well, let's open darkness detection and increase spacing to maybe 25 or even 35, and cells count half is going to be 3. Well, this is a grid with points where our sun line traces will go. They don't even need to lay on ground. I think that such scan will be enough. Now we can delete this draw debug sphere, and we have to add this vector to some array. So let's create a local variable in our grid scan around player and call it local grid points. Of type vector, and select an array. Here get local grid points and call add. Add the result of make vector function. And on completed of for each loop, of first for loop, we will have an array of points. Now we have to do a line trace. Let's create a new function and call it trace sun to trace position. And we will have an input called from of type vector and to of type vector. It will give us an output called hit of type boolean. Or not boolean, of type hit result. Well, here we're gonna do a line trace by channel. From goes to start, to goes to end. Trace channel is gonna be visibility, and let's draw it for 1 frame. And return a hit. Compile and save. Open grid scan around player. And I think let's move allocation a little bit down. So on here, on return values, let's subtract some value, something like 50. Compile and save. Now on completed of for loop, we're gonna get our local grid points and call for each loop with break. Connect completed to here. And we're gonna call trace position. From is gonna be sun location. Or maybe not. Let's delete it from here because we're not gonna use only sun. We have to do it for every light on our scene. So after grid scan around player and after calling it from a scan, we have to call something like, let's create a new function called trace sun. Here we're gonna use our array that we're not returning yet. So on completed of for loop, on grid scan around player, add return node. And let's return positions of type vector, and it should be an array. And connect a local variable called local grid points to positions. Now, on trace sun, we will have also an input called positions. Here for each of a position, we are adding a for each loop with break. For each of them, we're tracing a position, and an array element is gonna be to location, and from location is gonna be sun component that we have got earlier, and we're gonna get its world location. Right after that, we're breaking a hit and checking if it was a hit. And if it was a hit, we're gonna get an impact point and count its distance to a player. Let's get a character here and get actor location. And count distance to an impact point. Okay, now we have, we can, I think, print. Let's print a distance. And we're doing trace sun. We should do it on a scan. Right after, or in function scan, right after grid scan around player, we are calling trace sun. Well, it looks like sun position is incorrect. Let me check it and begin play. We're getting, let's add a breakpoint to each of the branches. False. False. So looks like sun component is correct. Well, Okay, it looks like it doesn't work with ultra dynamic sky. Yes, because directional light doesn't is not located at the real world location of the sun on our scene, so directional light is not located there. It's only sun located there. Well, by the way, we don't need a location of a sun, but we still need a sun component. So we're not gonna get a world location of a sun component, and we're gonna trace from grid points towards sun. So every array element of a trace sun is going to from, not to. And we have to know at which direction sun is shining. So let's get sun component and get rotation. World rotation here. We have to get a forward vector. It's gonna be a direction of the sun. Now we have to multiply it by -1 because we're tracing from player to sun and not from sun to player. Multiplying it by -1. And this is gonna be a direction of a player if he was looking to a sun. And let's multiply it by some distance. So we're gonna make a trace to some distance, and let's convert first vector to a float, and we're gonna trace on 5,000, for example. Next, we have to add this value to a place from which we are tracing. Let's add to an array element this vector and connect it into 2. Compile and save, and now let's check. Now you can see that our traces are going from a player to a sun. Well, and if we don't have a hit, then we can assume that there is nothing between us and the sun. But we may have an issue. Like if you're staying with something like this. Or between something. And honestly, I don't think that it is an issue because that's a reason why we are having a grid. So now we can know whether a sun is shining on us. And we should not count distance from an impact point now. We have to count the distance from an actor location and a place from which we were tracing. So in this case we will know what is a distance of a closest sun trace. So we will have to find a minimum distance from these array traces. So let's create a new local variable and call it minimum array distance. Local minimum array distance of type float. And make it a single object, not an array. Compile, save, and let's set it to something big. Now here we're gonna get a local minimum array distance and set local minimum array distance. And if there was a blocking hit, we're connecting this. A new value is gonna be minimum between local min array distance and this distance. So when a loop will end, we will have a local minimum array distance. Now let's check it. Let's check if let's print. Let's print a minimum array distance. Also, we should do this not when there was a hit. We should do it when there was no hit. So when nothing is blocking our line trace. So we're gonna do it on false statement of a branch. Now we can see that a local minimum array distance is 50, but sometimes it prints us our ten thousands. That's because array starts to go may start to go from the under of the landscape. So on grid scan around player, let's remove previously added subtraction of 50 from return value z and plug z by default. Maybe it will not print us. No, it still prints. Trace sun. Maybe I have a wrong print somewhere here. No, only one print string, and I'm printing local minimum array distance. Let's add a branch here. And check whether a local minimum array distance greater than 10,000. If true, we gonna print hello, and I'm gonna add a breakpoint here. Okay, we have 49 positions. And there was no hit. There was a hit somewhere. So if there was no hit, then we're setting a local minimum array distance. Do we mean between a grid point and actor location distance? Okay, the problem is that I have added here a type of my character, and these values were printed for him. Now you can see that 0 is printed. That means that a closest array comes directly to an actor. And if we will go here, you will see that the closest array is somewhere here in distance of 35. And now here no race, no trace, and no race cannot reach us. So we're in a dark area. And if we will come closer to an edge here, then it will trace. Well, that's fine, but we may have such an issue when we will come to a house, for example, stand here, and you can see that distance now is 105. That's because part of grid points are generated out of a house, and trace comes from them. Well, how can we fix this? we're gonna create a new function and call it validate grid positions. We'll have an input of positions of type vector and array and an output of correct positions. Here, for each of a position, we're gonna do a line trace by channel. Start is gonna be this position, end is gonna be a character location. Here we gonna break out a hit and check if it was a blocking hit. If it wasn't, then we're adding this location to an array. Let's create a new array, local validated points of type vector and make it an array. Let's get it and add this position. So we will validate that there is nothing between a player and the grid position. One more condition about this is that we have to check whether a heated actor is our character. If it is our character, then we also should add this position. So let's get a hit actor and check if it is not equal okay, if it is not a blocking hit or hit actor is character. So hit actor equal to our character. Let's add OR statement and plug this here, and this OR goes into branch. Then we're adding this point to our array. Finally, when a loop is completed, we're gonna return these correct positions. Connect local validate points to correct positions. Now open scan function and before trace sun, plug validate grid positions and make these positions as an input of this function. And correct positions goes into trace sun. Compile, save, and now let's test it again. Now let's move closer to a wall, and now you can see that this issue is not appearing. Also, we will not see anything here because collision for my window is a little bit broken. Let's fix this. Let's select this window where it is. I think it is this one. This window frame. Let's open the static mesh and show simple collision. You can see that collision here doesn't take in place space in this window frame. So I have just removed this collision. You can select collision here and remove it here, or remove it manually by selecting it in a viewport and tap and delete. Now I'm gonna add a box simplified collision, scale it a little bit, duplicate it, like this, and save. Also, I would like to check whether my window by itself has a correct collision. Yes, it has. Now let's try it again. And unfortunately, my window doesn't pass anything. Maybe that's a problem with a wall. Let me check a collision for my wall. Also, it's incorrect. Let's add a collision, a box simplified collision here in a very quick way. It's not very precise. Save it now and test it again. And now, near window, we can see that some rays are near us. They're not perfectly on us. Maybe we'll find such place when it will return us 0, like here. But now it works in a more precise way. Now, what we're gonna do, let's open back our darkness detection, open trace sun, and disable open trace position function, and set draw debug type to none. So now we know our local mean ray trace. In the best possible way, it is 0. 0 will mean that we're totally on the sun, we're visible in the best way. This value, this big value, will mean that no rays touch us. Also, I would like to increase our grid scan around the player. I'm gonna open a scan and select 5 here, because I want to see some values even if I'm staying deeper in the shadows, like here. Like here, I'm still seeing that there is a ray close to us on a distance of 200, so that it's not very black here. It's shadow, but not a total shadow. It cannot be very precise, but that's the way how we will detect this. Now we can we should set somewhere this parameter. Let's open the trace sun function and add a return here. Select trace sun function and in output return closest ray distance of type float and make it a single. Now on completed, we're gonna return our local mean array distance. Compile and save. Well, now back to our BPC stealth system. And we have a function called calculate current stealth factor. That is calculating current stealth factor depending on such parameters like is crouching and if our character is hiding somewhere in a bush. And now we will add a new factor as a sun effect. So let's open initialize function at first, and we have to get a darkness detection component. So right after everything here, we're gonna get a character and get component by class. Select a component class as BP darkness detection. Check if it is valid. And if it is, we're promoting it to a variable called darkness detection. And now In darkness detection, also let's open a scan function, and here after trace sun returned us a closest ray distance, let's promote it to a variable called closest ray distance. Compile it and save it. Now back to BPC stealth system. And let's open a function called calculate current stealth factor. Well, now let's add a new sequence node and connect this debug print to Zen2, and on Zen1 we will modify current stealth factor depending on sun array distance. Let's get a current stealth factor and let's subtract some value. We're gonna subtract some value depending on sun array location. Let's get a darkness detection component from our variables and get closest ray distance. Let's divide this closest ray distance to some value. So by default, we should subtract 0 when closest ray distance is 0, and we should subtract, oh no, we should subtract much more than 0. Okay, if it is 0, then we should subtract nothing. That will mean that player is on the sun now. If a closest ray distance, for example, is 200, then it will mean that we're far, that a closest sun ray is too far. Or maybe let's divide it by 300. But you can check this value depending on your settings on the grid. I have removed a print, I think. Let's add the print again. So now 0 means I'm under a sun. And the largest distance is something around 250. So on 250 we should return something like, I'm gonna divide on 250, you may check it in your own project. Something like 1. Now we should clamp it because sometimes we may have values bigger than 250. Let's clamp it between 0 and a maximum effect that a sun can give us. I think that 0.3 is fine. So we're gonna subtract 0.3 and set a current stealth factor to this value. And we should do it on Zen1 sequence node. Compile and save. Now let's start, and we can see that now stealth factor is 0.9, 1, now it's 0.7, because we are in the dark, 0.6. Well, why it is 0.6? And a closer we are to a sun, and more visible we are. I think that 0.3 is too small value, so I'm gonna change this in this clamp from 0.3 to 0.5 as the maximum. Okay, that's fine, but we have one more thing to do.